created the stub mandrel, we've got the clearance here, undercut, and then we've got the bolting face here. So if we try the wheel now, it goes on and it bites on that outer face there. So now we just put the holding bolt up the middle, and now we've got the whole thing perfectly true and clamped. It's true on diameter and it's true on the back face, and that's the important thing. That'll make the wheels run true. So now we have to be very careful. We've set the top slide over to 3 degrees, and we've got a tool in which will enable us to have the 20-degree flange angle and the right root radius here, and we're going to have to turn very carefully using purely the top slide, feeding in on the cross slide but never moving the saddle. So we'll just see how that works. As we take the first cut, we're slowly changing this parallel thread for a tapered one, but the carriage is firmly locked so that all of the feed goes on the tapered top slide, and gradually we'll see the run out in this wheel come away. So now we have to go back, leaving the carriage well alone, put another 10 thou on the cross slide, and now feed in again. And we go until we get a perfect root radius. We'll have to stop now. So now we feed in the final 5 thou, 10 thou, and this is the final cut. And what we're going to do is now we're going to go right in, cutting the 3 degrees and the root radius. When we get to the middle, the root radius will clean up, giving the 20 degrees and the radius and the same diameter on every wheel, and that's the critical thing. This is scatter, and we can stop there. And while we're at it, we can just use the profile tool to give us a nice chamfer, because we'd like a nice 45-degree chamfer on that edge, because that'll help us through point work. Okay, so we still haven't moved the carriage, that's the important thing. Okay, so that's the end of the first wheel. I chose the smallest of the 4 so that we could make sure we clean up on all 4 wheels. Okay, now without moving the carriage, I can change this wheel for the next one, which has a perfect bore and a perfect back again, because we've just put that right. Put it on the mandrel, hard up against the face, and we know now that when we turn, we're going to turn this true and to the same diameter as the other wheel. So this is number 2. So there we have 4 wheels whose bore is square to the back, whose tapered surfaces are identical in diameter, and whose flanges are of various ODs, but they've all got the 20-degree lead, and when we just machine and profile the ODs, they'll all be identical. Okay. So now we've made a jig which has a boss for the same as the wheel diameter, and we've offset it by exactly 1 inch from centre. There is the centre mark there, 2 bolt holes, and what we're going to do now is put each one of the wheels on in turn, fasten them on, and then bore the crank pins holes at exactly the same distance, because quartering is not just about getting the wheels the same, it's about getting the crank throw and everything the same. So that's the next job. So now we're going to slocum. The hole's got to go slowly because this is horribly out of balance. What we're going to do is just to make a hole in the centre hole in the crank web, just to make sure that we've got it in the right place. Just deep enough to be able to pick up and stop. So now we're going to drill. We want to drill this out to we want to drill it out to 1/2 inch, and then we're going to use a boring bar to bore it perfectly. But what I've got to do at the moment is to drill both through the wheel and through the jig at the back, so I can get a hole in which to work the boring bar. Now I can go through with the 1/2 inch. Go through the jig again as well, because again I want to be able to get the boring bar right round the other side. We're into the steel of the jig now. So now, because we can't rely on the drill to have drilled straight, we're going to just take a tiny bit out of the bore, just enough to make sure that it's absolutely true. Now I don't need to go through into the jig, so I think I can stop there. Tiny bit more cut on, and then I'm going to follow through with the reamer, and then all 4 holes will be identical. So I'm going to make a note of that reading. Now it's the reamer into the cast iron, no need for lubricant. In we go. Oops. Nice and gently. And then we know that all the holes will be the same diameter. There we have the first crank pin hole drilled on the jig, and we'll do the other 4 and we'll ream them at the same time, so that we'll get the all the 4 crank pins in exactly the same position. So now, when all 4 wheels are done, the acid test is to combining all the errors is to measure the gap between the 2 bores, because that takes into account the accuracy of that bore, the accuracy of that bore, and the distance between the centres. And if you look, we've got 3/8, 3, 3/8, 3/8, and 3/8, and I've got very dirty hands with the cast iron, but I think that's a very satisfactory result. Okay. So now we've centred the end of each axle, and what we're going to do is turn down. We centred them in the steady because you can't trust the 3-jaw. Mine's pretty good, but it wants to be perfect. So now we put that in the chuck, and what we're going to do is to support it on the tailstock. Can't really do this with one hand. Tighten the chuck, and what we're going to do now is to set the length with the saddle stop down here, so that we get exactly the right length of turning, so that the back-to-back's right. Okay, so now we check that for diameter. 690, that's fine. And we check it for length. Very difficult to do, again with one hand, and that should be 7.7. It's a little bit light, but that's fine. Okay, so now I'm going to do the other end. So now, having set the saddle stop, we can now turn, knowing that this is bang on centre, and return to the top slide reading, which was previously calibrated, so we get each wheel. See, there we are, we're up against the stop and back, so we know that's the right diameter and the right length. So now we take the axle out, we turn it round, we line it up with the end of the tool, and then we tighten the chuck, which of course is extremely impossible one-handed. But there we are. So now we're ready to turn this second axle to the same length and diameter as the other. So now, as a double check, we take one of the wheels and we place it on, and it pushes easily to about halfway, and that will come off again. So that's fine, I'm happy with that. So the next thing is to set the back of the jaw of the milling machine of the vise absolutely parallel and straight with the axis of the milling machine, because what we're going to do is we're going to use the ability of a V-block to be at perfect right angles to create the two surfaces at right angles. But it does all depend on having the back face of the jaw here perfectly parallel to the running of the milling machine. So we now need to set the milling machine to the centre of the axle, and what we do is bring the carriage back on the handle here until we just get a touch with the laser pointer on the outside. Then we zero the digital cross slide across here, come to the other side and go until we just get the same touch here, and then that gives us there, and that gives us the halfway point in the axle. So now there's the keyway, 1/16 of an inch deep by the length of the journal, and it should be bang in the middle. But even if it isn't, as long as we do the same with both axles, they'll be nicely quartered. Okay, so we're now going to turn it through 90 degrees using the square surfaces on here. So now we swap the block to the other end. We've turned it through 90 degrees. Here is our keyway that we've just done, and of course the right hand crank has to lead, always remember, in steam locomotives. So there's the left hand crank and there's the right hand crank, which we're now going to mill on here, safe in the knowledge that it's absolutely square against that V-block. Okay, so now there we have the axle, and we've got to be very careful to put the second axle in exactly the same way. So we've got one crank there, the right hand crank leading the left hand crank, and I think that looks pretty good. I don't know whether you can see it, but nice clean keyways. Okay, so now we're going to do the whole thing again with the second axle. We come in from the back and we're going to press down on here, which is a bit difficult to do with just one hand. Tighten the vise, and we are running against the back edge there. We're still on centre. We're going to put one keyway there, that's the right hand keyway, and then we're going to put the left hand keyway here. So we've got right hand keyway leading, as we should have. So there we are, two axles, each with the keyway there and there, and if you look at it, the right hand crank is leading, the left hand crank is trailing. All we have to do now is to make sure that the wheels get their keyways exactly in line between the axle hole and the crank pin hole, and then the quartering will be perfect. Okay. So here's the tool made out of a bit of 3/16 square, and that goes into the tool holder, and the Allen key tightens up nice and tight. Although the Allen key is only locking the tool, all the force is against the back of the bar. That's it. So now we can put the wheel on and cut the key. So this is my setup for slotting. I've got my cross slide set up at right angles to my boring table, and I've got a crude chuck driven slotter, and the tool goes backwards and forwards with the correct shape in it, and I don't know whether you can see, the tool is coming in and out of the hole at the back, each wheel sitting on a peg, and we will hopefully get all 4 wheels identical. So now we're doing the second wheel, and we're going to have to come a bit more like that, and what we're going to do is to feed in. Are you ready? So can you see the end of the tool, but don't get your hand in the cut. There we go, first cut. And now we want to feed in 60 thou from that point. So off, let the jig fall, turn it round, and there, with a mucky finger, is our second keyway bang on the line. And when these are all put together, all 4 wheels will be identical. Thank you. So here's the objective. We pushed that wheel on and the keyway is lining up with the keyway on the shaft, and we turn it over and the keyway is at 90 degrees. It's not quite lined up yet because it's still a push fit, but you can see that this is the right hand crank here, and this is leading, and this is the left hand crank, and this is trailing. And provided the second set of wheels are put together the same way, even though they might be a bit out, these 2 wheels will have perfect quartering with the coupling rods and the crank pins. So that's how it's done. Finish.